For this problem, we refer to the figure shown. Assuming all pulleys are frictionless, we need to compute the maximum safe value of weight W so as not to exceed the tensile capacity of the rope that is equal to 150 newtons. Now, the way I deal this problem is by considering the free body diagram of each individual pulleys. So let's call this pulley 1, pulley 2, pulley 3, pulley 4, and pulley 5. And let's analyze them one by one. So let's start by analyzing pulley 5 because we have a known value of tension that's equal to 150 newtons. So at pulley 5, we have exposed tension T is equal to 150 newtons. And we have a unknown force here going downward, and a force here going upward. When taking moments at the center or by noticing the symmetry of the figure, this should also be equal to 150 newtons. Therefore, the downward force here must be equal to the sum of the upward forces. That is 150 plus 150 newtons. This is equal to 300 newtons. Now we can proceed analyzing pulley 4. So this one is pulley 5. So for pulley 4, since this force here is 300 newtons, this force here by action-reaction is equal to 300 newton. And if this force here is 300 newton, this force here, like I said earlier, by taking moments at the center or by noticing the symmetry of the figure, you will get 300 newtons also. Therefore, this downward force here is equal to 600 newtons. Now we can proceed with analyzing pulley 3. So for the third pulley, we have a 600 newton force that comes from the pulley 4 and the downward force, which can be solved by summing up the upward forces of 600. We get 1,200 newtons. Now for pulley 2, we have an upward force, vertical force, and a downward force of equal to 600 newtons, which comes from the pulley 3. And by symmetry, this is also equal to 600 newtons. Therefore, the force going upward must be equal to the sum of the two forces downward. This is equal to 1,200 newtons. This is for pulley 2. Now for pulley 1, we have a downward force of 1,200 that comes from the second pulley. Therefore, this tension here should also be equal to 1,200 newton. And for the upward force, this is just equal to the sum of the downward forces. That is 2,400 newton. Now we have the values for the tensions. We can now proceed on solving for the weight W. Now we try to cut this segment here. We expose the tensions going upward. So this tension here, this comes from the first pulley, pulley 1. It has a magnitude of 1,200 newtons. And for this cable here, which comes from the second pulley, it has a value of 600 newtons. And for the third cable, which comes from the third pulley, it has a tension equal to 1,200 newtons. So to get the weight, we sum up force vertical equal to 0. This is negative W plus 1,200 newtons plus 600 plus 1,200 equal to 0. You can solve for weight by summing up the upward forces. This is 1,200 plus 600 plus 1,200 equal to 3,000 newtons. Therefore, the answer is letter C.